Hello guys, welcome back to another lesson for the Python complete course. Hope you guys have practiced previous session well. In this lecture, we will continue with our for loop and we will study what we can do with the range function also. So keep practicing with me. Range. Now let's combine what we have learned. Instead of simply printing the range, we will use it in a loop. Come type with me in VS Code. What do you guys think we will get? Remember, start is 1 and stop is 6. But 6 is not included. So the output should be 1 to 5. Let's run it. Exactly as you can see on the screen. Now, with a different approach, let's print only even numbers. Or I range 2, 11, 2. And then we write 2, 9, and we are starting from 2. We are stopping before 11 and we are increasing by 2. So what do you think we will get? Let's check. Exactly. Prints all the even numbers from starting from 2 to 10. Now, what if we want to print odd numbers? Think. Yes, we can start from 1 and then increase by 2 till 10. Now, the output will be, yeah, all the odd numbers from 1 to 10. Notice how changing the starting point and step completely changes the sequence. Now let's move forward with our slide. Reverse counting. So far, we have been counting forward, but loops can also count backwards. This is where a negative step becomes useful. Let's say we want to count from 10 down to 1. So we can write, keep practicing with me. All right. range starting from 10. Then we are doing what? We are counting backwards. Means negative and moral and then and then. Now, let's break this down. Starting at 8, starting at 10, stopping before 0, and moving each step by negative 1 each time. So, Python produces backward counting starting from 10 to 1. Let's run it. Definitely. This is very useful for countdown programs. Now, imagine we are creating a rocket launch simulation. We could write this code and then print lift off. Now, the program counts down from 10 and finally displays liftoff. Let's run this code. Yeah, this is a simple example, but it demonstrates how loops can represent real world processes. Now, moving forward with our slide. Looping to a string. So far, we have used loops with numbers, but here's something interesting. We can also use a for loop to go through a string. Remember what a string is. A string is simply a sequence of characters. For example, when we printed name is equal to Python. Yes, the string is Python, which is enclosed in double quotation is a string. The string contains six characters, which are E, Y, H, and A. For loop can visit each character one by one. Let's try an example. For example, this Python takes the first character, store it character, and then moves to the next and continues until it's run this. Now, for a real example, Let's say we want um, to use. Let me show you with the code. Now, in this code, every time the loop sees a character, we increase our counter by 1. This gives us the number of characters. Of course, Python has a built-in length function that can do this more easily. But I'm showing you this example because it helps you understand how loops processes information one at a time. So let's run this code. Yeah. So it prints the number of characters which are 6. Moving forward with our slide, looping through a list. Now let's take another important data structure, a list. Suppose we have a list of students. Students is equal to, let me show you this. So instead of printing each student manually, we can use a loop. For example, for student, student in students, print student. Python takes the first item, then the second, and then the third, then the fourth, and it continues until every item has been processed. Now let's run it. Yeah. Connecting this through a real world connection. Imagine an e-commerce website. There might be thousands of products stored in a list. If we want to display each product,
we can use a loop. For example, for product to product print product product. Very sorry, it asks for the indentation first, so be careful with it. This is a very common pattern in programming. Take a collection, loop through it, perform an operation on every item. Let's run this file. So each product is listed in this individual. Moving on to the next slide. Now we are going to use loops for something slightly more interesting. Let's calculate the sum of several numbers. Suppose we have numbers which are like we want to calculate their total. One way would be to manually write 10 plus 20 plus 30 plus 40 plus 50. But what if there are thousands of numbers? We obviously need a loop. Now, let's do this with a loop. So total, let's starting from 0. For So let's understand this very carefully. We start with total is equal to 0. This is our starting value. Then
The loop takes the first number 10.
we add 10 to total. So the total becomes 10. And the next number is 20. So the total becomes 30. Then 30 is added. So then the total becomes 60. And this continue until every number has been processed. This idea is called an accumulator. We start with a value and continuously update it as the loop runs. Now let's try it with a shorter version. Python also provides a built-in function called sum. Is like this. So if I run this, it prints our total 150, which is also right. But again I am showing you the loop version because understanding the logic is more. Let me in this. Yeah, this one. Because understanding the logic is more important than simply knowing a built-in function. Now, moving forward with our slide. Now, let's build something practical. We are going to create a multiplication table, and this time instead of hard coding the numbers, we will ask the user for the number. So let's code this. And thus the Python will take input from the user instead of hard coding a number. For this we have to type number is equal to int. So this is our code. Let's run this code to find out. So this is asking us for entering a number. Let's try it with 7. Oh, Python will calculate all the multiplication from 1 to 10. With 7 and run it. This is a great example of why loops are powerful. Without the loop, we did have to write 10 separate print statements. With a loop, we write the logic once and let Python repeat it. Now, pause the video. There is a challenge for you. Your challenge is to modify this program. Instead of always printing the table from 1 to 10, ask the user for both starting and ending value. For example, if the user enters 5 and 15, the program should print the multiplication table from 5 to 15. Do not worry if you can't solve it immediately. Try to think about which part of the range function needs to change. Pause the video and give it a try. Excellent. At this point, we have learned how the for loop works and how powerful range function can be. But what if we don't know beforehand how many times a loop should run? That's where the while loop becomes useful. In the next part, we will learn while, compare it with for, and then move into break and continue statement, infinite loops and nested loops. So let's move on. Introduction to while loop. Now we have learned the for loop. We used the for loop and when we knew how we wanted to repeat something, for example, if I want to print something 10 times, I can use this. But there are situations where we don't necessarily know exactly how many times the loop needs to run. Instead, we want to keep repeating something while a particular code is true. That's where the while loop comes in. The easiest way to remember it is a for loop is often used for known sequence or number of repetitions. A while loop, whereas, continues as long as a condition remains true. Think about simple real life example. Imagine you are filling a water tank. You don't necessarily say fill the tank exactly 37 times. Instead, you might say keep filling the tank while the tank is not full. That's a while type situation. The condition controls whether the repetition continues. Now let's see the basic syntax. Given on your screen, while condition then the statement. Python checks the condition. If it's true, the code runs. Then Python go back and checks the condition again. It is still true. The code runs again. Yes, continues until the condition becomes false. On to our next slide. This is a very important slide. Let's create our first while loop. Suppose we want to print the numbers from 1 to 5. So we can write this like, let's code this. Let's understand this line by line. First, we create I is equal to 1. This is our starting value. Then we write while I is less than or equal to 5. Python checks whether I is less than or equal to 5. At the beginning, I is 1. Is 1 less than or equal to 5? Yes. So Python prints 1. Then we have I plus equal to 1. So is an iteration, so I becomes 2. Python goes back to the while condition. Is 2 less than or equal to 5? Yes. That prints 2 and I becomes 3. This continues until I becomes 6. At that point, is 6 less than or equal to 5? No. The condition becomes false. Python stops the loop. Now, there is a very important thing to notice. What is something extremely important? We are changing the value of I inside the loop. If we don't do that, the condition may never become false. So that can create an infinite loop. We will discuss that short. Let's move on to the next slide. So let's compare the two loops. This is a very common question for beginners. When should I use for and when should I use by? Yes, but there is a you can know the sequence of number expectations. The for loop is not. For example, when numbers to one. Login system. We don't necessarily know how many attempts a user will need. We might say, keep asking for the password while the password is incorrect. That's a good situation for a while loop. Side by side example. Let's print 1 to 5 using a for loop. And now using a while loop. Oh. They both so don't think that one loop is always better than the important thing is understanding the problem the, that makes us yeah. Now let's talk about something that every beginner should understand, which is the infinite loops. An infinite loop is a loop never stops. Sometimes infinite loops are intentional. For example, some programs are designed to keep running continuously, but most of the time, especially as a beginner, an infinite loop happens because of a mistake. Let me show you an example.
Don't have this care. We are never increasing. Where remains one method asking is one this time or yes. Is one yes. If you accidentally run like this, problem C and control C turn no. No. It changes every time. Eventually, the condition becomes false and the loop stops. Let's run this. Right? Yeah. No. Let's move on to the next slide. Sometimes we want to stop a loop before naturally finishes. That's where the break statement comes in. Break means immediately exit the loop. Let's see a simple example. Now let's think about what happens. The loop starts at 1, ends 1, then 2, 3 and 4.
When I becomes 5, this condition becomes 2, and Python executes. Okay, that immediately stops the entire loop. So 5 is not print. So the output is this. Now understand the real life example. Imagine you are searching through a list of products for a particular product ID. Once you find the product, you don't need to continue searching through the remaining products. You can use break to stop the loop. This can also make programs more efficient. Now let's learn about another loop control statement. This one is called continue. Break and continue are different. Remember, break stops the entire loop, while it continues with the current iteration and moves to the next one. Let's see an example. Now let's predict the output. The loop starts at 1 and 1 is not equal to 3. So it prints 1, then 2 is printed. When I becomes 3, the condition is true. Python executes continue. It skips the rest of that iteration. So A is not printed. But here's the important part. The loop does not stop. It continues with 4 and then 5. So remember this simple difference. Break means I am done, stop the loop. And continues with this one, move to the next. To the next part. This is the most important one. Next one. Now, we are going to learn something slightly more advanced. We have already learned nested if statements. We can also have nested loops like that one. Nested loop simply means a loop inside another loop. At first, this might sound complicated, but let's understand it with a simple example. Imagine a classroom. There are three rows. Each row has four students. We could use one loop to represent the row and another loop inside it to represent the students in each row. Let me show by an example. Yeah, let's understand what happens. The outer loop starts with row 1, then Python enters the inner loop. The inner loop ends to all four students. Only after the inner loop finishes does the outer loop move to row 2. Then the inner loop runs again. This continues until all rows have been processed. As it is taught. Nested loops are also very useful for creating patterns. For example, Now let's run the outer loop controls the number of rows. Inner loop controls the number of steps. And this concept becomes very useful when you start running pattern-based programming problems. Excellent. We have now learned some of the most important loop concepts in Python. We started with the while loop. We compared and while, for and while. We have learned that infinite loops are now and out of world, will entry and continue. And finally, we introduce nested loops. But we are not finished yet. In the final part of this lesson, we are going to focus heavily on problem solving. We will take the concepts we have learned and use them to solve actual programming problems. We will also go through the common mistakes, discussions, community challenge, quiz and homework. So don't skip the final part because that's where we will turn all this theory into actual programming logic. So this is the final part of lesson 5 and I've made the problem solving section longer so with useful recording. Now that we have learned different types of loops and loop control statements, it's time to use them for actual problem solving. This is one of the most important parts of learning programming. While the syntax of a for loop is one thing, being able to look at a problem and decide how to use a loop, solve it is a completely different skill. And that's the skill I want you to learn. So whenever you receive a programming problem, don't immediately start typing code. First understand the problem. Let's learn a simple process that we can follow for almost every programming problem. Step 1. Understand the problem. First, read the questions carefully. Don't worry about the code yet. Ask yourself, what exactly is the problem asking me to know? Let's take an example. Suppose the question says, write a Python program to calculate the sum of numbers from 1 to 10. Don't immediately start writing code. First understand, we need the numbers from 1 to 10. Then we need to add all of them. Step number 2, identify the input. Next ask, what information does my program need? In this particular program, we don't even need user input because the numbers are already given. But imagine the question says, ask the user for number and calculate the number from 1 to that number. Now we need an input. Identify the output. Next task, what should the program print? In our example, the output should simply be the total sum. Step 4. Think about the logic. Now we think about how to solve it. We need to go through numbers one by one. But immediately suggesting you can use a for loop range function. Step 5 is right. Before write Python, we can write our logic like start total at 0. We go to every number from 1 to 10. Add each number to total. We finally print total. Notice that we haven't written a single line of Python yet, but we already know exactly what the problem needs to do. Step number 6. Let's understand it. Step number 7. Try run. Now let's manually trace the program. Initially, at step number 8 is finally running the program. This process is extremely useful. Try to develop this habit instead of immediately jumping into code. Moving on, these are some common mistakes. Now let's talk about some common mistakes beginners make when working with loops. Understanding mistakes is just as important as finding the correct syntax. So mistake number 1, wrong indentation. Python will complain because print statement is not intended. Correct version is also changed. Remember, indentation tells Python which code belongs inside the loop. Forgetting to create a while loops wrong here. You never change that. So it remains one forever. The condition remains true forever. That's an infinite correct. Mistake number 3. Misunderstanding range function. This is another very common mistake. For example, as it is given, some beginners expect 1 to 3 4 5, but Python produces 1 to 4. The stop value 5 is excluded. Mistake number 4 is the wrong loop logic. Sometimes the code runs perfectly without producing the answer to expected. That's logic error. That is why you should try run your code before assuming it's good. Now it's your turn. I'm going to give you several problems. Pause the video and try to solve each one yourself. I'm also going to write the answers, but first try to yourself. These are the three format questions. Why each and everything and then talk about the correct answer. These are the
Money challenge for you. Now, we're going to do a slightly bigger challenge. I want you to build a simple number game. Here's the idea. The computer has a secret number. The user gets multiple attempts to guess it. For now, we'll set the program. We will keep the program simple. We can choose the secret number ourselves. At that secret is equal to 7. Now I want to allow the user to make multiple guesses. This is a perfect situation for a loop. Let me read the question. Yeah, there are three attempts. Every time they add a guess, we compare it with secret number. If it's correct, we then select and use it the loop. Wait. And if it's wrong, the loop continues and gives another attempt. It's this. Now, pause the video. Can you please this program? Crowd is playing too high if the guess is greater than the secret and too low if the guess is smaller. I will read the comparison of letters and if any friends that we have learned in the previous year. Going forward, what will be the output? Option twist. So, here's the homework. Before moving to the next list, if you want to practice this code, just watch the solutions. Really write the code yourself. Homework is print numbers from 1 to 100. Sum of the first and natural numbers. Multiplication table for a user given number. Print all even numbers with 3. Reverse. Print a list using lib. Count vowels in a sentence. Print a right triangle pattern of stars. Simple guess the number game with while statement. At least three problems. Try solving them without looking at the previous examples. Congratulations, you have completed another major Python topic. Today, we have learned about P. Started by understanding why loops are necessary. Then we learned the for loop. We learned how range works. We learned how to count forward and backward. We also learned how to convert strings and lists. Then we introduced the while. We compared for and while. We learned about infinite loops and how to avoid them. We also learned two important loop control statements which are break and continue. Finally, we introduced nested loops and practice solving problems using them. But remember, learning the syntax is not enough. The real skill is being able to look at a problem and decide, can I solve this using repetition? How should the values change? That's how I love programming logic. Before moving to the next section, slicing, cutting methods, and will solve several skin-based problems. Thank you so much for watching my video. Keep practicing, keep making mistakes, and keep improving. We will see you in the next